Hello, everyone, and welcome. Thank you for joining us for today's session, The Realities of Battery Technology and Modern Electrification. I'm Becky Schultz, Vice President of Content for KHL's Power Division and editor of Power Progress. I'll be moderating today's discussion. Battery technology is advancing rapidly, and it's a topic that's getting a lot of attention across the industry. But as many of you know, the reality in the field doesn't always match the headlines. There are still important challenges around performance, reliability, system integration, and costs that engineers and OEMs are navigating every day. So today, our goal is to take a more grounded and technical look at where battery technology truly stands. We'll be discussing what's working well in real world applications, where there are still gaps between expectations and performance, and how emerging technologies may or may not address those challenges. We'll also spend some time talking about the practical side of electrification, including system integration, design trade offs, and what OEMs need to better understand when selecting and implementing battery systems. I'm joined today by a great group of panelists. Joe DiCarlo, Director of Sales and New Business Development at Panasonic Energy, Alex Meyer, Sales and Marketing Manager, EMEA at Forsee Power, Lucia Salcido, Senior Product Manager at Flux Power, and David Del Pozo, CEO of Elsa Solutions. Thank you all for being here. We'll be starting with a few questions to frame the discussion, and we'll also leave time for audience Q&A. So feel free to submit your questions throughout the session using the Q&A box in the upper right corner of your screen. With that, let's get started. Our first question is, how would you describe the current state of battery technology across your respective markets today? David, why don't we start with you?
Yes, we can start from this point. Thank you for the question. Thank you for allowing me to participate to this very nice conference. I'm very proud of being here and represent Elsa Solution. What we see in a recent period with the electrification is that the energy density of the battery technology has improved a lot. And also the market is sort of recognizing these features. So new application, new market requests, and new projects are coming and are focused on the fact that they are feasible. One of the key enabler is energy density, and also the fact that there is a very easy opportunity to make a selection on custom solution, not only for the battery shape, but also for low voltage and high voltage batteries. So ranging from 24, 48 volt from up to 800 volt is possible today. And it's possible by many suppliers. So that is an enabler for project electrifications.
Alex, would you like to comment?
Yes, thank you. And thank you for the invitation. So I fully agree with David. The technology today is no longer a bottleneck. It's really about fit for purpose. You've mentioned energy density, and indeed, LFP has made huge progress over the last 2-3 years, now reaching up to 430 watt-hour per liter with over 7,000 cycles, making it obviously a TCO leader, especially for heavy-duty use. At the same time, also speaking about lithium-ion chemistries, NMC and LTO remain essential for specific needs. So today, success is not about choosing the best chemistry, but the right one for your application.
Joe, would you like to comment as well?
Oh, got it. Can you hear me, Becky? Great. Yeah, I think I'm going to echo on what Alejandro said. Right. Years ago, we used to wonder, can I see your roadmap because I want to determine whether or not there's a battery that exists that do that. That question isn't even being asked anymore. The battery technologies are available today, and I think everyone on this panel, has very good technologies and this fit for purpose. And I think, as Alejandro mentioned, and the technology is available today. So we're not asking that question anymore. It's more about what battery is best fit for my application. And you're looking at it from an optimization perspective. We're looking at it for the integration perspective. And then, of course, as there's people on this call are probably important for us, can we do it at a cost that our customers can afford to buy the product? So I think, in today's world, we're not really asking. It's more about what the right chemistry is, and then making sure that we are integrating the battery into the system, not as a component or a drop-in, but really working with the other integrators, whether that be the power supply unit or whether that's the charging system. So working closely with companies like Delta Q so that you can ensure that the battery is optimized, right? So again, I think it's not the chemistry anymore. There's plenty of good chemistries that are going to do the job. It's more about, what the right chemistry is for that particular application and purpose.
Great. I'm going to start off with Alex with the next question. Let's discuss what lessons have been learned from the field data and how that is influencing not only current battery system design, but actionable items for the users in the field. Alex, can you start us?
Yes, indeed. For users on the field, the reality is very harsh. So we spoke about the chemistries, but let's zoom out and look at system level. So we see hard temperatures, duty cycle, charging behaviors that are driving performance on top of vibration profile, especially for earth moving application, and all that should be taken into account. So clearly, battery system design is just as critical as the chemistry itself, including all processes like cell-to-pack assembly, BMS safety, multiple levels, and durable performance with optimized cooling system.
Lucia, what about your thoughts?
Yeah, so a lot of things that we've been seeing on the field data and what's influencing is basically the transition from lithium and connected systems has increased the data visibility through telematics. But a key challenge that we're seeing is how we turn all that data into actionable alerts or actionable insights. So many customers right now are collecting large volumes of data, creating these data lakes, and there's not much thought yet on how to data mine those data points and how all these systems need to be interconnected. Right now, everyone releases their own telematics, their own dashboard. So users right now are logging into different dashboards. So users come up with like 40, 50 different dashboards. So it's more about how the users now are asking, pointing to what Joe just said, is how can I interconnect and integrate all these systems? So a lot of users are asking, hey, can your system communicate to their dashboard? Can I see some data points from their dashboard in your dashboard? So that's the evolution I'm seeing. Yes, so much data that we have, but the thing is, what do I do with all this data? How can I turn this into alerts or actionable alerts? How can I do predictive maintenance? How can I leverage AI to get better insights on my operations?
Great. Joe, what about you? What do you see out there?
Yeah, I'll just, again, I think what Lucia mentioned was absolutely perfect in that, the real life in all of my experience in designing and developing batteries and then working with these customers and then using these, the real life data is never how you originally predicted how the product was going to be used. It never matches. It's always much more harsh. The partial charging, the long idle periods, the extremely large temperature swings, all of the things like that are significantly different than how you originally had planned it. So I think using that, field data, really trying to get real use modeling data to be able to predict and then integrating that into the system is really how products should be designed today. That's how you should be working, looking at the system and the integrator overall performing to help meet. I mean, the end goal is that we want to, the battery supply wants to help you sell more products, right? And unfortunately, batteries are blamed for everything, whether it's regardless of, and I don't think it's a function of having a bad cell, right? You don't have a bad cell, but you could have a really good cell placed in a really bad spot inside of the battery. Because of the way these mismatches are with how the product is being used, oftentimes the battery gets blamed, but in the end, it could very well be a good cell just placed in a really bad spot.
David, do you have any comments to add to that?
Yeah, we're not going to comment about data because that would be the topic of future of data management next year, maybe. However, besides the joke, I think that I totally agree with the other panelists because from my personal point of view and also from my professional point of view, we have to tell them automotive electrification standards from industrial electrification practice, which are two separate words. So maybe most of the customer comes to us with ideas or solution which are generated somehow from their automotive knowledge or from what they read in newspapers. But then the numbers, the manufacturing technology, and also the specification are way different from automotive industry. And the same applies for data. So you can make modeling when you have 100,000 piece, 200,000 piece manufacturing batch. You cannot make the same when you talk about 500, 1,000, or 2,000 piece. Those are two different words, in my opinion.
All right, great. So next, let's discuss which emerging top technologies you believe have the most practical potential for industrial and off-highway applications. Joe, would you like to begin with that?
Sure, I'll start with that one. Thanks, Becky. I'll put this in really three buckets. I think from perspective, I think you're going to have your battery technologies that are out there that are going to be emerging. I think there's panelists on this call that have their emerging technology that really will find a good suit for that. So whether it's advanced lithium iron phosphate platforms, NCA, NCM, cylindrical cell type platforms, sodium ion, but there's a lot of good platforms there, as well as platforms that are currently being developed. So there's new technologies and roadmaps that people are developing, many of which that Panasonic is developing for future use in these applications. So I think battery technology is one of those that's emerging across a lot of new chemistries that people are trying to produce. The second bucket I'll put that in is in module or pack technologies. So I think we're advancing a lot on the BMS, on the BMS management type systems, with whether it be, BMS technology, analytics, and as well as connectivity. So a lot of that is all emerging, as well as a technology to help support this particular, these applications in this market, making those batteries also modular and scalable. So I think in today, you're designing modules for Gen 1, but you should always be considering Gen 2, Gen 3, Gen 4, so that when new technologies are advancing, you're able to simply put those new technologies into the module with a minimum amount of NRE, development time, and everything. Because unfortunately, you used to have 2 years to develop a battery or to develop a device or an application, and you don't have that anymore. Thanks to AI, everybody wants something in a month or a week, and so that really that sort of thing, that scalable type needs to really be part of the decision. And lastly, this will be my plug for Delta Q, in that you really need to start looking at the charging system as well. So how does the battery best fit, and how and work with Delta Q closely to make sure that the charging system is optimized for that application. So shallow discharges or pulse charging or other ways to help optimize the battery. So those are kind of the three buckets that I'll do more for from the emerging technology piece.
David, what are your thoughts on that?
I totally agree with Mr. Johnny Carlo. My personal opinion is that there will be a continuous evolution instead of a revolution. So all the different branch of technology will improve little by little, year over year. At the same time, new emerging family technology like sodium ion and solid state technology are advancing and coming to the market. So they are maybe no longer just a promise, they are available. Then there is trade-off about pricing, feasibility, and application-specific requirement, but these are available. So a very wide range of technologies will also improve the range of application that any one of us will be able to design in terms of battery pack. And the charging speed, because we are always worried about energy density, but when there is the possibility to have available high charging power, then most of the problem can be solved in the other way.
All right, Lucia, do you have any comments on that?
Yeah, so on the BMS, we're looking at more advanced technologies. So BMS will no longer be just monitoring voltage, current temperature. It will be more of an integrated system that will be defining what real-time safety interventions or self-balancing, predictive fault detection, then that we can tie it directly with AI and analytics, which is like a natural extension of the trend of new BMS technology. So with AI and analytics, we'll be seeing predictive maintenance. So that will flag degradation of the hardware, optimizing charging scheduling, depending on usage patterns that the system starts to learn to better help users with the peak shaving, better rating, charging ratings during peak hours to better optimize the cost of using those technologies. And just like fleet-wide benchmarking scorecards, how users are utilizing their equipment, basically. We can talk about state of health. So AI will be helping with state of health, helping users know what current percentage of their or how healthy their equipment is, so it can help them with their replacement cycles, better plan on how to utilize their equipment. If they do need to do some rotation strategies, move equipment that is being highly used into lower usage areas. So, and then once those equipment have reached their end of life, or at least the state of health percentage that is better used for motive power, we can talk about how we can better give a second life strategy into those units. So maybe this battery will no longer be useful for motive energy like material handling or ground support equipment, but there's still enough life out of it to repurpose it into energy storage or other technologies like that.
Alex, would you like to share your thoughts as well?
Yes, please. So to me, the real innovation today is happening within the existing chemistries. LFP is a great example, so lithium iron phosphate. Now closing the gap on energy density while keeping advantage in cost and lifetime. So LTO on top of it still leads for ultra fast charging, high power system, especially at megawatt scale, up to 1.5 megavolts, with high reuse of components from the rail industry, for instance. So key trends is rather optimization instead of disruption, especially on off-highway where customers are not looking to experiment, but they want proven and reliable solution that would work in the field.
Excellent. So, what should OEMs and system designers better understand when they're selecting and integrating battery systems? Lucia, let's have you start with this one.
Yeah, I cannot emphasize the importance of understanding like application duty cycles. So that's something that users and OEMs need to be really adamant in. You need to really understand what type of environment or duty cycles you're putting your equipment in. It's not going to be the same environment if you put a battery into a cold storage application into a regular warehouse. So often what I've seen is that OEMs go price based and not, or basically what is most commonly sold without thinking about the total cost of ownership, right? So depending on the duty cycles that you'll be applying, maybe the most cost the lower cost option at the time will be the best option. But then if you take everything into account and the replacement cycles, maybe that battery doesn't last as long as a higher price one. But yeah, you need to take into consideration the environments you'll be supplying this batteries into. So thermal management, capacity, BMS technology, interconnectivity. So all of these, also you need to take into account that you're speccing the right battery for the right usage. It doesn't work out when you're over speccing. Maybe you got a battery that is over capacity for the rating of your truck. So this leads to over speccing, and you're with an over spec battery that probably lasts the whole shifts, but maybe you could have used a lower capacity one.
Great. Alex, why don't you comment on this next?
So first, I fully agree with Lucia, and you really need to define first if your usage is heavy or low usage. So you have to think at global scale, machine level, and if we go back a bit, and if you are at earlier stage, there is always a compromise in between the battery and powertrain by selecting first the most appropriate voltage. So, David, you've mentioned 24, 48, up to 800 or even more. So that's always worth questioning integrators and partners like Zappy Group before you proceed. So it's a must to take into account all suppliers from the start and not at the really end of your project.
David, would you like to comment on that?
Yeah, what I see based on our experience is that it is not always good to look at one components only, but to have a kind of vision of the whole architecture. And I would like to say that most of the project we have took part at have been successful because the partners and the customer were talking together. So there was the possibility to have a kind of interface and to understand each other, the trade-off of the inverters, of the battery, of the charger, and to focus on the real application specifications. So we are not sending product, we are sending projects, and the customer is not sending just a diesel or internal combustion engine machines, but is sending a complete new machines where maybe the parameters to be considered is not only the price, but is the efficiency, the system durability, the replaceability of each component in case of damage. So I always recommend to have a global architecture vision from our customer side and share the information with the suppliers and allow also potential suppliers to exchange opinion each other.
Great. Joe, why don't
Sure.
you wrap us up?
Yep, will do. I think that's the one thing about going last is that you just have to, kind of ditto a lot of everybody hit it on the head. I think the recommendation here, everyone wants to chase the latest shiny new toy, and that isn't always the best fit for that purpose, right? Just because somebody has something new with the highest capacity, it's not always going to be right for the application. So, you could go for lower. You just have to figure out. You just have to go for what the looking at what is right fit or is best fit for the purpose. And then I think Alex mentioned it in terms of making sure that you're also working with the other subcomponents inside of it. Don't wait for the last minute to say, oh, by the way, we need a battery for this, because then you may wind up having to, find a cell or a technology that really isn't fit for that particular purpose. I think, to win in this landscape, it's not about chasing the latest battery, but what the best system is that's going to be the right fit for the lifetime of the application or the purpose of the application. That's what's going to help sell, more of the products, because customers are going to buy more if the fit is right.
Great. Now let's discuss what are the most common integration mistakes or oversights that you see in the field. Joe, why don't you continue and kick this off?
Sorry, I was on mute there for a minute. I think, from that, I think it just goes back to a lot about what we had discussed earlier in terms of oversight. Really, I think it's going to be down to a couple of things that I already mentioned before. One of it, which would be, making sure that you are using and having the collaboration. I mean, it's if you have a PSU supplier, you got the battery supplier, you got if you're doing your own BMS or a BMS supplier, collaborate with everybody in the same room at the same time, because everyone is going to be able to share how to put together and optimize the overall battery. So have all of those in the discussion from the very beginning. This way they can all design together for that. The second is really don't chase the latest technologies, right? I think make sure that you really understand real life data about how the battery is going to be used in the field, how your customers are going to really use it. I think Lucia mentioned about a lot of dashboards where customers are putting information, listen to that information and utilize that on how to best design the system or best design the cells. Because again, as I mentioned, it's batteries. We get blamed for everything. Oh, it's a battery failure, right? Even if you see a fire on an airplane, it's like, oh, it's got to be a battery, right? It's a lithium battery. But I think making it's not a function of a bad cell. It could be just a function of the cell not put into the right location. So make sure that you understand the thermals, you understand how the battery is being built, better equipping your BMS, and those are the things that I think you kind of want to focus on when don't overlook those when you're designing the overall module.
All right, David, why don't you go next?
Yeah, I would like to add that system integration shall not be underestimated, and the fact that the best components are always the best components, but they do not make the best system. That is something that is very strategic. So allow the suppliers to talk together for the power system, for the voltage selection, for the canvas integration, which sometimes is missing or something that will come later when we are assembling the prototype or the demo machinery, the demo vehicle. And applicable standards, which can be very tricky because for some industry sectors, applicable standards are not yet developed for electric vehicle or for hybrid vehicles, but are very important to understand where the how the system shall be done.
Lucia, what are your thoughts?
Yeah, I completely agree with what has been said. Basically, most common failure adoption points I see is like highlighting the lack of consideration for duty cycles, and as well a misalignment between systems. So battery supplier delivers a battery, charger supplier delivers the charger, but how are they interconnecting? Is it either CAN? Is it just a handshake? So yeah, basically, I agree. You need to bring all of your suppliers together to better communicate and have a strategy on how to deploy the systems so everything works seamlessly.
Alex, do you have anything to add to that?
Yes, so I fully agree with the colleagues. First one would be thermals. Second one would be CAN protocol. Make sure everything is talking with the right and the same language. And third, as David said, the standard, what's applicable and not overspecking. So about the standard, I would like to say that especially in Europe, but in whole countries are following the same templates basically. It's anticipating the compliance to battery passports because it's a must now, but will be mandatory soon with QR codes, full access data. So again, related to that, you also need to foresee and to anticipate the cybersecurity topics around all those data lakes. So make sure all those aspects are taken into account before building prototypes.
Excellent. So, for our last scheduled question, what advice would you give OEMs navigating battery decisions in an increasingly complex and fast moving landscape? Lucia, would you like to start?
Thank you. Yeah, so we need to emphasize to users, OEMs, customers, that they need to focus on the total cost of ownership rather than just the upfront unit cost. This is particularly important when you're transitioning from internal combustion or lead acid into lithium fleets or electric fleets. So you need to evaluate what is the long-term value of adopting these technologies and implementing it strategically into your operations versus just the short-term cost of adopting these technologies.
Joe, what are your thoughts on this?
Thanks. I agree with Lucia. I think again, 5 key points for this, and some of these I think we've covered in a lot of the questions, but anchor the decisions on real world, right? So not based on roadmaps or specs or anything like that. I think looking at total cost of ownership or life cycle value is going to be key. Treat batteries as strategic systems, not as an afterthought or a drop-in. I think there's a graveyard full of companies or products that tried to do a drop-in and it just wasn't fit for purpose, right? It was easy to do, but it just wasn't the right way to go. And then lastly, look at and favor scalable type of opportunities when you're looking at design. So, I know it's a lot of work or extra work on the front end to think about Gen 2 and Gen 3 when you're only designing Gen 1, but you have to give yourself an option to be able to scale the module up. And we do a lot of that with a lot of the customers today. I mean, Panasonic in generally is not the easiest company to work with because we ask a lot of questions, but the questions we ask are generally because we want to try to make Gen 2 and Gen 3 easier for us to be able to scale to so that you can and eventually sell more. I mean, the end goal here is, we have a motive, right? I want to sell you more, and then you want to sell the customers more. So I think, looking at those, and then lastly, I think they're just designing for flexibility, and not just chasing the latest technology. Make sure you're looking at what's right for your customer in the application.
Excellent. Before we jump into our audience Q&A, Alex, do you have any other comments, or David?
No, that's all to me.
Okay, great. Well, let's dive into our Q&A then with our audience questions. To start off with, I think we've touched upon this a bit during the discussion, but are there any new chemistries that you foresee traction post any lithium-based chemistry solutions? Who would like to start? Joe, do you have any thoughts?
Okay, sorry, the mute and unmute was sticking a little bit. From a chemistry perspective, Panasonic is always looking at our roadmaps in terms of advanced technologies, and we're looking more at solid state. Seems to be a technology that more people are looking at. At least I think Davide mentioned it earlier in that at least for the foreseeable future, most of what we're seeing is going to be a lithium base, right? Where we're going to continue to make, or the chemists, we're going to continue to make incremental changes in those. But I think for beyond that, in the 5-year or so type of time frame or roadmap, solid state could be a technology that we're seeing could be potentially a good technology for the future.
David, do you have any thoughts on that?
Yes, I have. Thank you for asking. Actually, I think that we have been presenting a semi-solid state technology, a solid state technology Gen 1 prototype last year, and this technology is quite promising. So beside the continuous evolution of current technology, sooner or later there will be some improvement, especially for what concerns safety of the product, intrinsically safe batteries. That is something that can allow the whole battery technology to make a giant leap.
Great. Alex, anything?
Yes, I agree. So it's always worth mentioning sodium ion indeed, because it's a right compromise in between LFP and lead acid batteries. But again, I would say off-highway OEM are not looking to experiment. So for that year and next 2-3 years, I would recommend using existing chemistries that are proven and mature, and then going to off-highway once it's proven.
Great. Lucia, any thoughts that you have on that?
Everything has been covered.
Okay, sounds good. Another question that came in: how do you see the development of LTO versions in the future? Lucia, would you like to start with that?
Oh yeah, well, LTO, it's a rather newer chemistry around lithium. I've been asked a lot about LTO, specifically in the ground support equipment, just because the duty cycles are larger. It handles temperature ranges way better than LFP. But right now, that technology or that chemistry, the total cost of ownership is not there yet. So right now, I think we rather stick with LFP or other chemistries until chemistries like LTO start to make sense from a financial standpoint, because I would say that the total investment for companies is not there yet within that chemistry, just because of price point, but it's a very stable chemistry, but the cost is not there yet.
Alex, do you have something to add to that?
Yes, indeed. LTO is definitely something you need to look not at front cost, but at TCO level, because lifetime. I mean, you can reach more than 20K circle of lifetime. But indeed, as Lucia said, it's not always optimized for I would say battery electric, full electric machines, but rather for hybrid system or very high utilization vehicles, extreme duty cycle like mining or heavy construction, where LTO, I believe, would remain one of the best technical solution, but it won't be mass adoption. It's not a niche, but it would adapt to specific usage.
Joe, do you have a
Yeah.
question or comment?
Yeah, no, I think everything that was said already. I think from a depending upon the application, there are some applications that are really good fits for LTO. And as for the reasons that were mentioned, with whether you want really fast charging times or wide temperature ranges or really long duty cycles, if you can afford the total cost of ownership, it's incredibly expensive. And it's not because of a material perspective. It's not the materials used that are expensive. it's all of the additional processing that needs to take place to manufacture LTO. And it's also very difficult, right? There's a reason why there's only, there's a reason why there's quite a few NMC, NCA, LFP. So there's a reason why there's a lot of manufacturers out there. And there's very few LTO suppliers that are out there because the cost is good and it's not quite giving that total cost of ownership. Panasonic doesn't make LTO, but if the model becomes right and the costs become good, then rest assured we're probably going to make LTO to support the market. But right now it's not part of our plan simply because as Alec mentioned, it's just not a big enough market and the cost drivers are too expensive.
David, do you have anything to add?
Nothing to add except for the fact that battery in the future will be more and more application driven, and therefore the choice of the chemistry will be application driven as well.
Right.
Great. Another question that came in: with all this incapability of interoperability, are there any initiatives in the industry to standardize data analytics and characterizations? Why don't we start with you, David?
Thank you for the question. This question is very difficult to answer because from one side, I see we are in Europe. I mean, my company is based in Europe, so interoperability sometimes is good, but regulation compliance in Europe is like a paramount, something you have to be even scared, I will say, because we work in an environment where compliance to regulation is mandatory, of course, but it's also a very heavy part of engineering job inside our company. So I like interoperability. I like the fact that there are standards in course of development in order to allow all the data to be read by different manufacturer or different device. But compliance, when it comes to data, the compliance in Europe is something that we have to take into account very carefully. We are leader for regulation production. In Europe, we are leader for regulation production. Remember it.
I won't comment on that. Lucia, why don't you start next?
Yeah, the trends that I'm seeing on how to standardize data analytics is how we are interconnecting protocols between charger management systems and energy management systems, or BMS. So there's this open charge point protocol that's being used in the EV space. So basically, EV chargers send all their data to a charger management system, but we're seeing an adoption trend in the industrial space as well, in the material handling space, in the ground support equipment. And it's basically, how can I connect all this charger data into the cloud and then connect that data into my energy management system? That way we can see, okay, maybe the battery registered X amount of charge current, but the charger the charger's not showing that same data. So it's how we operate all this system so we can match and get the full scope or the full story of what's going on within those systems. So also, let's say I have the telemetry on the battery, but the user also has the telemetry on the truck. How can we interconnect those systems via APIs? Maybe I grab some details from the truck and then I send some details from the battery. So we can interconnect all the systems and match all the data into just one dashboard.
All right, Joe, any thoughts?
No, I think everything that has pretty much been said already in terms, especially with what Davide mentioned in terms of overall standards. So standards are always good because it helps to be able to establish a little bit of a program. I'm not aware of any outside of Europe is always. I'm not going to comment on what David had said earlier. There definitely is a lot of, especially when it comes to data, very sensitive in terms of that. But standards are good once And then once everyone is actually able to join in and follow those standards, as long as it fits what they want to do in an application, right? We've all been on so many boards with IEEE or some of these others where they want to create the standards, and as soon as it doesn't match with what somebody wants, then they want to go ahead and do something else. So I think it needs to be done at some point, but I'm not aware of anything that's being done in this market yet in terms of creating specific standards for these applications.
Alex, anything from your perspective?
Yes, at system level, when you've mentioned standards, I really believe I think first about charging, and especially on construction, zero emission sites. When you are mixing together a few vehicles in different brands, you want your machines to be charged or use the same mobile power unit or same charger, or even be charged on CCS2 chargers from automotive. So that would be done through standardization of protocols. And what's not taken into account a lot is the diagnostic, because that's also something you need to anticipate. If you want anyone be able to have easy access and diagnose your battery, again, you need to use a standard like UDS, for instance. So every OEM could make sure and access to your battery data and enable diagnostic by anyone.
Excellent. So, another question here is, given current battery limitations, how should companies evaluate whether electrification is truly viable for their specific application? Joe, why don't you start us off this one?
Sure. I think so. It's kind of almost a math problem, right? I mean, is it viable for your application, right? So real life duty cycles, looking at total cost of ownership, not just your peak specs. And if that number is better than what it is, what you have today, then it's right. It's a good fit for that application, right? So I think if the savings that you're going to get by electrifying is going to outweigh the cost of what it is going to have for you today, then it's a viable solution for electrification. Now, that being said, is that, get a good understanding of what it is that you're trying to design for, right? And then go out and find the right technology to support that. But that to me, it's a kind of a simple math equation to see whether or not it's viable.
Lucia, any thoughts on that?
Yeah. So adding to what Joe said, so matching the peak discharge to your battery data, doing a energy consumption investigation before deploying, and basically a power study to see if your facility can actually have or is capable of the charging infrastructure, has the electrical infrastructure to install or go full electric.
David, do you have any thoughts on that?
Well, no, I agree with my colleagues. I just want to add that sometimes the fact that the batteries can be repaired or serviceable shall be seen not as a limitation, but as an opportunity. And as Mr. Alexander Meyer said before, some off-highway applications require proven technology and also technologies that can be repaired. Okay, so the end user will be guaranteed that in case of trouble, the solution will be found.
Alex, do you have anything to add?
Yes, going back to the really beginning of our session, we already mentioned the density, energy density. I really believe it's not anymore a bottleneck here. So you would be able to match your energy demand for sure. But no, it would be rather about how to size the cooling system on your full system. So related to the powertrain and related to your environment. So to me, that would be the key here, enabler to say if your product, your machine is viable
Mhm.
to be electric or not.
Okay.
Mhm.
Another question that's come in, what are the most common performance or reliability challenges that you are seeing in real world deployments? Alex, why don't you continue and start on that?
Yes. So you said misconception of design from OEM. So again, what came up in my mind, it's about cooling. Many OEM are planning to up, and really that's also a key to take in to have in mind. It's time to market. If you OEM say I want 1 year, 1.5 year time to market, but then they want to develop the machine only for I don't know, Northern Europe, Netherlands, and then they come back and say, oh no, finally I will also sell it to Middle East. That's something not easy.
Mhm.
So again, about cooling and anticipating, that's also going in the same direction than Joe said about Gen 2, Gen 3. You really need to anticipate, make room for the future and evolution of your product.
Mhm.
Since you mentioned Joe's name, why don't you
Mhm.
continue?
Sure. I mean, I think again, I think the misconception that generally people have that the highest energy density is what's it equals best performance, and that's truly not the case in practice. It's more about durability, thermal stability, and the way that the product behaves differently in the field. Especially in these very harsh industrial type environments. That's typically what I would suggest to people.
David, why don't you comment next?
Well, I would like to say that system integration is underestimated. So if you put together all the aspects, features that my colleague have just said, and may allow the suppliers to make a good system integration, make a good coordination and final specification of the whole architecture, then performance will come out and the project will be successful, in my humble opinion.
Mhm.
Lucia, do you have anything to add to that?
Yeah, I think the biggest thing is the thermal management of this equipment. So, when designing a new battery system, you need to take into account what Alexander just said. You're not designing batteries that will only be placed in cold environments. You also need to think about operations where, let's say, they're in Phoenix during the summer. So you need to think about thermal management, not just from a heating perspective, but from a cooling perspective. Also,
Mhm.
take into account the heating that will occur during charging events. That's something that's also been overlooked. How much heating the cells get while they're charging. Yes, customers want fast charging, but sometimes your operation cannot support that fast charging depending on the operating temperature or the outside temperature where you're putting your equipment in. So better knowing how to do better charging profiles to still support a fast charging, but with a temperature stability.
Awesome.
Mhm.
Uh, any other comments on that, or can we move on? It looks like we have time for maybe one more question. All right. How do you see battery technology evolving over the next 3 to 5 years in practical applications? Alex, why don't we start off with?
So yes, there will be evolution, but I guess, and I repeat, this would come from existing technologies. And
Mhm.
here, if I want to say a quick advice to OEM, we really need to start real world operation, not from technology ambition or a will to try and to use the last technology. Start with proven and mature technology. And in 2-3 years, indeed, if there are evolution in density, if your cell would be able to better or faster charge, then you could reuse it, but start with what's existing today and anticipate the evolution of tomorrow.
David, do you have any thoughts?
Yes, I think there will be an evolution of the technology. We have widely spoken about all these aspects during this call, but I think that OEM shall change their mind about the way they sell machinery, simply because they need to stop selling machinery. They need to find a different approach, different solution, selling service, accounting for total cost of ownership, renting products, and allowing the end user to have a different approach, and also allow the end user to be involved on the design, not because it is just an OEM exercise, but because it is an end user needs to see if something can be done in a slightly different way with an electrified machinery.
Great. Lucia, would you like to comment?
Yeah, I think we're going to see a transition where users in the adoption will not be as like hardware won't be just enough. It will be all about the interconnectivity between software. I believe that software will be the future of battery technology and AI and large language models. How can all this technology better help you strategize how to utilize your equipment? Battery systems will be able to tell you exactly when you were supposed to charge, what time. We're already seeing that. State of health algorithms to better help you with replacement cycles. So basically, the machines will be telling you from a software perspective how to predict their usage. You will be getting monthly reports on your usage, insights on how to better manage those units. So the learning curve from transitioning from other technologies into electric right now, I believe it's still, from the user standpoint, it's still a significant learning curve. But with all the user insights and actionable insights that they'll be getting, I believe that curve will be diminished within the next 2 to 3 years.
Great. Joe, we have like a minute and a quarter.
Yep, that's it. I think that
jump in.
I think the incremental changes, as everybody has already said, and much more in terms of system management. I think, but we'll start to see a lot more use of AI in how we can best improve overall battery performance.
Great. Well, this has been a fabulous discussion. Thank you to all our panelists for being a part of it. I'm sure they'd love to hear your questions if you want to reach out to them, if you have additional questions after this webinar session. But thank you to everyone who's tuned in. We really appreciate your time, and thank you for joining us.